Alright guys, this is now day 4 of factoring quadratics. So it's a fourth day of trying to learn this process and seeing different starting points. So today, before we go over examples, I'm going to show you one special case. It's called the difference of squares. So there are two special cases when factoring quadratics. We're going to only focus on one for now. It's the difference of squares, and here's how we can recognize when we have it. First off, when you look at your quadratic, like in this example here, there's no bx term. See how it's just x squared and then a constant? So you're missing that bx term. The second part is that it's going to be a difference, so you're going to have a minus sign. This is required in this special case. And it's a difference of squares, which means it's a difference of two perfect squares. So in this example, x squared minus 16, x squared is a perfect square because it's just x times x. And 16 is a perfect square because it's the square. It's a 4 by 4 square. So whenever you have a difference of two perfect squares, you can factor this immediately with this shortcut. It'll simply be a plus and a minus, so different signs. And all you're going to use is use your roots here. So you say x plus 4, x minus 4. In other words, x plus 4 will be one factor, and then x minus 4 is the other factor. This is an immediate factorization of this quadratic because it's a special case. So here are my two factors. Now to verify, just real quickly, I'll just do this once. Let's go ahead and multiply out our two factors and see if we get back to our original quadratic, which is x squared minus 16. So using the box method, x plus 4, it's a 2 by 2 box, then x minus 4. If I multiply, x times x is x squared, and then x times 4 is 4x. Negative 4 times x is negative 4x there. And to finish, negative 4 times positive 4 is negative 16. And notice how in this situation, when you look at your like terms, what do you notice about these two like terms? Do you see how they're opposites? In other words, 4x minus 4x will cancel, so these go away. And so you're left with x squared minus 16, which is your original quadratic, so you went full circle. So with that, let's look at example A. It says, factor the quadratic equation, so x squared minus 49. First, notice how there's no b term, it's the a and the c, so I recognize that. Second, I have a minus sign, so far so good. Third, do you see how x squared is a perfect square of x times x? And 49 is a perfect square of 7 times 7. So this is another example of a difference of two perfect squares. So to fact this would no work, I simply just put in my two factors, plus minus, and I just use x plus 7, x minus 7. And I can quickly factor that quadratic. I don't have to use the x factor or the grouping, I can just do it almost in my head. Example B. What about this one? So here's, again, that's like there's no bx term, good. There's a difference or a minus sign, good. So the question is, are these perfect squares? So let's check. Isn't 4x squared the same as saying 2x times 2x? That's a perfect square. And 25 is 5 times 5. So again, this is an example of a difference of two squares. So to factor, I can just do this pretty automatically. I'll just use the roots. So I'll put 2x plus 5, 2x minus 5, and I'm done. 2x plus 5, 2x minus 5. These are the factors of this quadratic. Now for example C, it says, is x squared plus 4 a special case? So take a second, go ahead and pause the video, think about it, and when you hit play, I'll give you the answer. So what do you guys think? Is this a special case? Well, it's not. And it's not because this is not a difference of squares. So this is not a difference. So it doesn't satisfy this special case. Okay, with that, guys, as a summary of this one little note, recognizing a difference of squares when factoring is very important. Guys, it'll give you guys speed when you factor quadratics. You want to be able to do this in your head. So with that, let's do a quick speed round. Pause the video and see if you can do this in about less than a minute. All 4 examples. They really should just be done in your head. So pause the video and give it a shot. Alright guys, welcome back. Hopefully you tried those really quickly. So I want to just show you how to get the answers here. So notice how they're all going to be differences of perfect squares. I want to make a point that when you guys write the factors, you can put the plus and the minus in any order that you want. It doesn't change the factors. So you can put the plus first, the minus second, or the minus first, the plus second. That does not matter. It's your choice. So what are my factors for D? It's 4x plus 9, 4x minus 9. For E, it's x plus 10, x minus 10. So that backwards, sorry. For F, it's 3x plus 1, 3x minus 1. And then for G, it's x minus 12, x plus 12. So I can very quickly factor these special cases of quadratics when there's no bx term. It's a difference of 2 perfect squares. Guys, with that, the rest of these examples are just that. Notes are done. So actually, I'm sorry. Let me show you guys example H. It's just a little bit different from before. But here are our same steps that we've had out for 4 days. So in example H, first off, this is in standard form. Good. Step 2 is there a GCF? So in this example, there is a GCF to start. Notice how I can take out a 3 out of both of them. So if I divide by 3, I'm left with x squared minus 9. Notice how at this point, if I look at just this quadratic, see how there's no bx term? And it's a difference of 2, in this case, squares. So if I look at it, isn't x squared just x times x? Isn't 9 just 3 times 3? So here I can factor quickly as x plus 3, x minus 3, because again I can apply today's idea of difference of squares here. But I did have a GCF to begin with here, so in this response I should put it back in the answer. So in this case, this would be my final answer for this example. With that, guys, pause the video. Please try example I. It's kind of like H. And then at that point, we'll be done with the lesson. Give me a quick little summary of how this feels for you. And then the rest of the examples are just going to be that. Try them, and then hit play. You can see all the answers. So please try I. Okay, so here's the answer for example I. So again, difference of squares after the GCF of 2. And it's x plus 1, x minus 1. And then drop the GCF down in the final answer. Alright guys, so at this point now, we're just practicing. Please try these 8 examples on your own, and then if you need help or want to check your answers, hit play, and then I'll just have everything worked out for you as an answer key. Good luck, guys. Alright guys, so at this point, this is a key for examples J through P. Just take your time, look at the work here. A couple of points I want to make about these examples. Notice how in example M, how my first step is that take out the GCF, and in this case, when I take out a 4x out of both of these terms, I actually have my factored form already. So that happens sometimes also. For example O, this happens to be a difference of squares, so I noticed that. So I just went from question to answer here. No need for all the work. And then example P down here, notice how in this case, as I did all of my x factoring and my grouping, at the very end I get 2 factors of x plus 3 and x plus 3. So there will be some cases when you get your factors, they'll be the exact same. So because I have 2 of them and it's a list of 2, I can write it as an exponent and say x plus 3 squared. So this will also occur as we move into more depth. With that, so pause the video here if you want, check the key, but I'm going to zoom in now to the challenge question. This one's a little bit different because in this example, notice how, if you think about your steps, step 1 in this whole process is to make sure you're in standard form. Standard form of a quadratic means it's equal to 0. And in this case, it's equal to 3. So this is a problem. So for a question like this, before we do anything else, we have to first move this 3 back to the left-hand side using the opposite. So if it's a plus 3, I'm going to subtract 3 to both sides, like that. And what I have now is a new question. It's x squared minus 4x minus 21 equal to 0. This is my quadratic in standard form. So I'd have to do this first and then go through my process. So here now, I can find that a is 1, b is negative 4, and c is negative 21. And I can go through my process that way. So I'll pause the video here again, just briefly, try to do it from this point, then come back, check the answer. Alright guys, so if you tried example Q, once we made that first shift, then it just falls like the other ones have by doing the x factor, and then finding your two factors here, going through your grouping, and then here you get x plus 3 as one factor, and then x minus 7 is another factor. So with that, that's today's practice. Tomorrow, guys, we're going to be having a little quiz. It'll be our trial run. So for tomorrow's quiz, please feel free to use your notes and just kind of get used to the platform of we're doing a quiz online. All right, guys, take care.